Hi, this video will be properties of definite integrals. And with our definite integrals, the big thing that we need to remember is that our summation, we are adding up different areas under bounded regions. So that is something that we definitely need to remember. And also the next thing, if we are below the x-axis, then we might be talking about a negative area. And then we can read our notation here. It's going to be read as the definite integral from a to b of f of x with respect to x. And then here's all the different parts of our integral that you need to know: our upper limit, the integral itself, and the lower limit. The definite integral is the whole thing put together. The integrand is your function, and then your variable of integration there, dx, is just going to be the x part. And remember that the definite integral can be used to find your net area, or a distance traveled, bounded by the x-axis, the function, and vertical lines, x equals a to x equals b. All right, so we have some problems to do. And with this, again, we are just going through and finding our bounded area. And that bounded area, we will need to look to see if it's above or below the x-axis. We will also need to be looking here with our different types of endpoints. One thing that we need to keep in mind is that our endpoints need to be in order. So if I have an integral that's from 4 to 0, then we need to change that. We need to change 2 and then put a negative and put the integral from 0 to 4. We always have our least on bottom and greatest on top. That's your lower and upper bounds. And then also we need to remember some formulas. Formulas that we need to remember: we have the area of a circle is pi r squared. The area of a trapezoid, 1/2 the height times the sum of the bases. You also need to know the area of a triangle. That's going to be 1/2 the base times the height. All right, so looking at our first question here, we're looking to see our area from 0 to 7. So we're going from 0 to 7. So we're looking for that bounded region there. So we're looking for this area inside here. And so if we do the math for that, then we've got 1/2 the height, which is going to be from here all the way up to here. So that's going to be 4 times the sum of the bases. Well, this base down here is going to be 1, 2, 3, 4, 5, 6, 7. And the top base is going to be 3. So let's see. 1/2 times 4, which is 2. 2 times 10 is 20. So that first area there is 20, or I know that area inside there is 20. And so we continue on, and we would try to find that area. I'm going to erase those vertical lines. And then let's go find our next area. That's going to be from 0 to 13. So from 0 out to 13 is going to be that region, which you don't have to find a lot of new area. You just need to find this area inside here. And if you do 1/2 the height, which the height is going to be 3, times the sum of the bases. Well, the bases, the first base, or the top one, is going to be 1, 2, 3, 4, 5, 6, times the bottom. It's going to be 1, 2, 3. So that's going to give us 9 times 6. It's going to be 54 over 2, or 56 over 2. So we're going to end up with 27 over 2, 13.5 is what we're going to get there. So we're going to have 13.5. And it's going to be negative because it's bounded below the x-axis. That's where that negative area is coming in. So here, if we put this together and say 20 minus 13.5, then that's going to give us an area of 6.5. Okay, and the same thing for number 3. We're going to go from -6 to 0, -6 to 0. Again, let's go find those boundaries. -6 to 0, so we've got to break here to here. So that looks like a semicircle. So we're going to find this region below here. We're finding that area. So we're going to do area equals, that's kind of hard to see, so let's swap it back over. So area is going to be equal to pi times r. Well, our radius is 3. It goes out to here. So 3 squared is 9. And we're going to divide that by 2 because we don't have a full circle. We have a semicircle. So my area there is going to be 9 pi over 2. All right, so now we're going to look from 3 to 3. So from 3 to 3, well, that's just going to be a single vertical line. From 3 to 3, there's no area in between that. So that's going to be 0. Okay, and so looking at number 5, it says from 7 to 0, so we've got to fix that. Those endpoints are not turned right. So we do negative, and we say 0 to 7. So -0 to 7, well, that's going to end up being like our earlier problem. This looks like number 1. Except for the signs change, so it's going to be -20. So then for number 6, we're going from 4 to 10. So those, we need to do some erasing here. Get rid of some of these lines. Okay, so for 4 to 10, let's see, I'm going to get rid of some of this. Now from 4 to 10, that means that we're going to go from here to here. So we need to find the area that is inside here, and then the area that's inside here. Okay, so that top area, you're going to have 1/2 base times height again, and if you work out this area inside here, you're going to end up with, from 4 there, you should end up with 8 for that area. And then if you work out this area inside here, you should get 13, or 15 over 2. Okay, so for number 6, if you work those out, you get here, you've got to swap these bounds, so it's going to be negative. And then you've got 8 minus 15 over 2. And so that's going to give you, let me slide my screen over a minute, all of that, what should that give you? Negative 1/2 once you work that out. Okay, so again, those are just trapezoids and you're working out those. I didn't work them out, but if you need to see them, ask me in class and I'll be happy to work them out for you. All right, so here on number 7, you're going from negative 8 to 13, so you're looking at the whole thing. So we knew this was negative 9 pi. We knew this whole thing here was 20, and we knew this whole thing down here at the bottom was 13.5. So what we didn't know was this triangle right here. So we can find that right quick. That's 1/2. The base is 2, and the height is 1, 2, 3, 4. So 4 times 2. So that area inside there is 4. So now we just go add all of those up. So we're going to have 4 minus 9 pi over 2 plus 20 plus 13.5. Okay, and when you get all of that put together, you should have 10.5 minus 9 pi over 2. We leave it in exact form. Okay, and then number 8, it says f prime at negative 6, and then f prime at negative 6, I believe it's not going to exist. There's a cusp or something going on there, especially when a circle ends up going into a triangle like that. So that's where we're going to get a cusp. So we're going to say here for this one does not exist. And then in question 9, we want f double prime at 6. So f double prime at 6 is here. Well, f prime at 6 is going to be a constant value. That's the slope of this line is constant. So I'm going to write f prime at 6 is constant. And so I know the derivative of a constant is 0. So then I know that value is 0. Now number 10, average rate of change. That's telling me that we need some slope here. And we're going to find slope over that interval. So we're going to find f at 5 minus f at 0 over 5 minus 0. And that's going to be equal to, and then f at 5 is 4, f at 0 is 0, over 5, so that gives you 4/5. All right, so let's erase some things on our picture for us to do number 11. If we can clear off some of these things. I think we've about cleared off. Oops, I cleared off the whole thing. That's not good. All right, so I think that's probably enough. All right, so on number 11, we have an integral from 0 to 2. So I'm going to go from 0 to 2. And then I'm going to take this bounded area, and I'm going to go from 2 to 4. So then I'm adding to it this area. And it wants to know, is that the same thing as just bonding the area from 0 to 4? Well, yes, it is. This is true. That would be the same thing. Okay, and over which values of x is f of x not differentiable? Well, that's going to be when x equals -6 and 0, 2, 5, 7, 8, and 11. Okay, on this page we have a lot of properties that we need to know. So do look through these properties. They are important. Something about number 3 for us to note is these endpoints are the same and these functions are the same. And so when that happens, you can put it back together or take it apart as one big function. So important. Another important property for you to know is that if you're integrating just a constant value, some number like 5 or 12 or 5 million, then you can pull out that constant value and then integrate the function. Question 5, or property 5, is saying if you just have that value, then to integrate it, it's just that value times the upper limit minus the lower limit. And then here on question 6, it's just a matter of separating these or putting them back together as well. So either way, on these, you've got these properties that would be good to learn, and we're about to use them. So here on these questions, we're going to go through and use those properties. For question A, we have here from A to B. Well, that's going to be messed up because we need it to go from least to greatest. So I don't know anything about the integral here from A to B of g of x. All I know is here with their endpoints going from here A to B, not B to A. So what I need to do is introduce that negative and swap my endpoints and make them from A to B of g of x dx. And then that's going to tell me that's the opposite of the integral from A to B of g of x dx. So that's going to be negative of -3, which is going to give me +3. On B, I know nothing about 2 times, the integrating 2 times, 2 times f of x dx. But if I pull out the 2, that's the integral of A to B of f of x dx. This I know something about. I know that's 2 times the integral here from A to B of f of x dx is 8. And so that's going to give me 16. Here, this is one that was talking about that just had a constant value. Then I know that's going to be 5 times b minus a. And that's all we can do for that one. For part D, we would separate these from A to B of 5 dx plus the integral from A to B of gx dx. And then you can go through and integrate those. So for D, that first part here, That's going to be 5 times b minus a plus, and then the integral from a to b of g of x is negative 3, so it's plus a negative 3. Part E, we would break this apart. So you have the integral from a to b of f of x dx minus the integral from a to b of h of x dx. And so you're going to have 8 minus 5 halves. So that's 16 halves minus 5 halves, so 11 halves. And then for this one, we can break up or put together. In this case, we'll want to put together. And so that's going to be the integral of from a to b of h of x dx. And we know that's going to be 5 halves. So that's how you use those properties, and we went through that kind of quickly. You might need to back up and listen to them again and see if you have any questions. Again, please ask me in class. Okay, to work out this problem, this is really a good equation for us to work with. We're going to break this apart. First, I'm going to group this together and then have this separated. So we're going to have the integral from 1 to 5 of 3 times f of x dx plus the integral from 1 to 5 of 4 dx, and this is equal to 34. So now I'm going to move out the 3 times the integral from 1 to 5 f of x dx plus, and then this is one of those properties, again, you have a constant value there, so it's just going to be the number times the difference in the upper and lower bound equals 34. So we're going to have 3 times the integral from 1 to 5 of f of x dx plus 16 equals 34. So I'm going to subtract 16 over. So I have 3 times the integral from 1 to 5 of f of x dx. That's going to be equal to 18. And if we divide both sides by 3, we get the integral from 1 to 5 of f of x dx is going to be equal to 6. All right, great problem there. One that you will definitely see again in your future. All right, even and odd functions. An even function, as a quick review, is symmetric about the y-axis. So if you have, let's do a better parabola. A parabola is definitely symmetric about the y-axis. And what this is saying is if you've got bounded area from 0 to 3, and say your area is bounded right inside here, and you know that area right there is 8, and then all they're giving you is for you to find the value here, that same function, but you're going from -3 to +3, then you're finding that same area again back here at -3. Well, these are mirror images of each other. So if that's the case, then this value would also be 8. So that integral from -3 to 3 of f of x dx would have to be 16. So an even function doubles the value. Okay, with the odd, an odd function is symmetric about the origin. So it does something like this. And if you were bounded from 0, or here you know from 0 to 3, the area is 8. So I'm going to chop it off and say, okay, I know this area right here is 8. And I'm going to go back to -3, and I'm going to bind that area. Well, notice this one is below, but it's the same area, low but same. So this time from -3 to 3 of f of x dx is going to be a +8 and -8. So it's going to be a 0. So odd functions cancel. All right, so we have two things going on. Again, even functions double the value, but odd functions cancel out the values. All right, we're just going to do one of these, and then that's going to be about it. What this is asking you to do is graph x plus 3. And when you do, you get a line. And you've got a point up here at 0, 3, and back here at -3, 0. And you can get that from your, do a t-chart. Let x be 0 and then let y be 0. That's where these points come from. And so your bounded region is sitting inside here. And so your area of a triangle is 1/2 base times height. So the area for this triangle is 1/2 3 times 3, which is going to be 9/2. So that's going to be your answer to this one. But y'all don't have to worry about those. We'll do these a different way.